So what I'm going to talk about is real test automation that we wanted to introduce 1.5 years ago. Then we decided to use robot framework, and we haven't regret. In my presentation, I would like to give answers for 3 main questions. First of all, what is robot framework? I would like to give a short overview. Second question is, why robot framework? I'd like to emphasize its benefits. And the last question is, how we use robot framework in our test project. Robot framework is a generic test automation framework implemented in Python. It uses the keyword-driven testing approach, which means that the test actions to be performed are separated from the test script. Keyword-driven approach is a high-level meta language that uses keywords that uses high-level business interactions. So this keyword means a high-level business interaction with a system. As an example for a keyword could be login to a GUI. This keyword call can be located in a so-called test definition file, while the implementation itself is located separately in another file, a test script file. And there we can see now the steps to be executed, the implementation of this keyword. First step is open a browser, then wait for some info, input username and password, click on a button, wait for some other info, and capture a screenshot. On this slide, you can see the high-level architecture of robot framework. The system under test can be tested directly with test libraries or using test tools. Test libraries are controlled by robot framework, while robot framework is controlled by the keywords and the test data. Robot framework is actually a set of available test libraries, which can be divided into 2 groups. First of all, you have the standard libraries available just after the installation of the framework, and the external libraries should be installed separately. Each library contains keywords that you can use directly in your test definition file, or you can reuse them by building your own keywords. Standard libraries implement common functions such as data handling or interaction with the operating system or with the tester while running text execution. A couple of examples for external libraries is Selenium library for web-based automation, database library for managing database connections and managing databases, and SSH library for remote connections. Now I would like to give the answer why robot framework. First of all, it is easy to use. Thanks to the keyword-driven approach, complexity can actually be hidden in the keywords, which means the test definition files are easy to read even for non-programmers. This makes it possible to maintain the code easier as well, because when you need to change something, you can change it only in one place, and many test cases will be affected. It is possible to attach tags to the test definitions, test tools, that describe its function or category, for example, smoke test or regression test, and you can get statistics generated by these tags, and you can also identify the critical tests. It's easy to execute test cases using a simple command line interface. With meaningful parameters, you can give what test cases you want it to execute or exclude from your test run. After the test execution, you will get meaningful logs and reports generated automatically. Robot framework is universal from many aspects. First of all, it's platform independent. As it is developed in Python, it can run on any machine running Python. As we have seen before, there are many test libraries that are available, and you can build your own test libraries as well. For example, if you need complex calculation, you can create a test library for that. You can also, these test libraries can be implemented in Python or Java, but there's a possibility to use other programming languages when using the so-called remote libraries, about which I will talk later. With those remote libraries, you can drive many test tools. There are plugins for continuous integration and build tools for the popular Jenkins as an example. Robot Framework is completely free as it is an open source software. It also comes with an integrated development environment. This front-end can be seen on the screen right now. On the left-hand side, there's a browser. Here you can see a content of a so-called resource file, test script file. You can see the variables and the list of keywords. On the right-hand side, there is the implementation of the keyword we have seen before. You can see the documentation, arguments, and this tabular syntax, which means each row is a test step, actually. Now, in the first column, you can see keyword calls, and in the further columns, the arguments. It also has the code completion, or here, keyword completion functionality, which means you start typing a couple of letters, and all keywords starting with those letters will be offered along with the documentation. That was all the general information about Robot Framework. Right now, I would like to show you how we use it in our test project. Our test project is responsible for the system integration test of Deutsche Telekom's mobile billing systems. We use a test automation server where we store the test definitions, the test cases. These are stored in SVN, but they could be stored in any version control system as they are actually normal text format. The systems under test can be tested many ways. We use database connections, web interfaces, and SSH connections. After the text execution, you can see the result through a web client that we have developed. And the test cases can also be reported to Hewlett-Packard Quality Center. We have seen this slide before, and I would like to show you how we broke down the keywords for our needs. So the first level is common keywords that can be used for all of the systems we want to test. These are rather technical ones. For example, backup a file, or should be no error in the log produced by the system under test. There are system-specific keywords. For example, log into the GUI we have seen before, or verify a specific contract mapping. And in this level, you can use keywords from the below level as well. On the test definition level, you can use keywords from both levels below. And these test definitions files will be stored in another location. After executing a test, you can see the result on this web GUI developed by our team. You can get all the meaningful information, for example, system under test, release, and so on. And when you click on the log there, you will get the following overall report produced by Robot Framework. The red one shows that at least one critical test has been failed, while the green one shows that all critical tests have been passed. You can see statistics by tag, by suit, or further detailed information about each and every test case, for example, execution time. When you click on the log again, you will see this log produced by Robot Framework. It actually contains each and every keyword call, and these keyword calls can be expanded. So you can go to the deepest level to check what went actually wrong in your test case. For example, there is a keyword call, which is a high-level keyword, should be no errors in log. Inside that, there's another keyword, grab string in file. It actually grabs for error in the log produced by the system under test and stores it in a variable. And then this variable should be empty, otherwise we get errors, so the test case is failed. These files are actually stored in XML format. That's why it's so easy to expand and collapse them. When you think it's the valid result, you can directly report them to Quality Center by clicking on Report button on the web GUI. Now I would like to share an issue we have solved using Robot Framework. Have you ever tried automating a GUI application developed in C or C++? It's actually really hard because of the constantly changing GUI object IDs. They keep changing from build to build. That's why it's very hard to identify them. That was the reason why we found an alternative solution, which is an open source image-based test tool. It uses image recognition to identify and control GUI components. Its name is Seculi. You can find all the information about it on the internet. We had another challenge. The GUI that we wanted to test was running on a remote Windows virtual desktop, actually. So we had to use the so-called remote libraries for Robot Framework. We had to implement a test library for Seculi in Java, as this is a Java application with a good API. How this remote library actually works can be seen on the slide right now. So a remote library is actually a proxy between Robot Framework and the test library running elsewhere. The communication between the remote library and the remote server takes place through XML RPC. Now I would like to show you a demonstration how this image recognition-based tool, Seculi, works with Robot Framework. We have a colleague who is so lazy that he's not even keen on playing, so he made Robot Framework do it instead of himself. So he actually automated a game, this breakout game. Maybe you know it. So the goal is to destroy bricks with a ball, but you have to move a little pedal underneath the ball in order to bounce it back. So how Seculi works is it monitors the part of the screen looking for the ball based on a pre-saved bitmap. And whenever it recognizes it, it gives it position back. And then, as it controls the mouse and the keyboard as well, it can move the mouse there, and this paddle, this bat, will be moved there too. So actually, we can see this video. The test case is started from right. The test library is running in the background. And there Seculi Googles. It types in Atari breakout and clicks on picture search, which is a hidden game in the Google search engine. I don't know if you did know that or not. You can try this at home. And actually it monitors this part of the screen, and wherever it finds the ball, it will move the mouse so that the paddle will be moved there as well. After 20 seconds of successful gameplay, the test case will be passed. It happened actually. So please note that all work and no play makes Jack a dull boy. With this valuable saying, I can close my presentation. You are free to ask questions.
We have time for one question. Or in the coffee break for more, of course. Oh, here we go. Then one question.
Thank you. My question would be regarding to quality center reporting. So actually it's two questions. The first is that if I get it right, you report only those results what you've checked beforehand manually.
Yes.
So it means that you are not automatically reporting all the results to QC after test case execution.
Yes, it's right.
Second question basically is that what type of library do you use for that purpose? So do you created an own solution for that, or is there an existing solution for QC reporting?
So first question, the answer is yes, we only report the test cases we have checked before. And the answer for the second question is we actually don't use a robot framework library for that purpose. It's rather a shell script. So on this web GUI we developed, there's a button, and to this button we can attach the shell script that uses the quality center's interface to report the test case.
So you're using QCX for this purpose?
Yes, I think. You're welcome.
Okay, then thank you very much, Tamás.
Thank you.